just graphed you, and this is crazy, but here's the intersection, so solve it maybe. Yeah, so we're looking at graphs and intersections and approximate solutions to equations. So I've just briefly described that as graphical solutions. Okay, so let's say we've got an equation like x squared minus x equals 5. We can use algebra to solve that. So we'd have no problem solving that at all. We would just simply rewrite that as x squared minus x minus 5 equals 0. And then normally we'd try and factorize it, but that won't really factorize. So we'll put an x in there. 5 can only be 5 times 1. So 5 and 1, and one's got to be a plus and the other's got to be a minus, plus and a minus. And it doesn't work, and even if you swap the plus and the minus around, it won't work. So, okay, so, well then what else should we use? Well, we could use maybe completing the square or maybe the quadratic formula. They are essentially the same as each other because the quadratic formula comes from completing the square. So let's say I'm going to use the quadratic formula. The number in front of the x squared is 1. The number in front of the x is minus 1. And the units term is minus 5. I'll just put in the 1s there, even though they're not there. I'll just put them in grey. So a 1 there and a 1 there. Okay. So that's my A. That's my B. And that's my C. And we're going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b is going to be negative 1. So that's just going to be 1 plus or minus the square root of b squared is going to be negative 1 squared. So that's 1 minus 4 times a times c. 4 times 1 times negative 5. So that's going to give us negative 20. So negative 20 all over 2a, 2. So that's going to give me 1 plus or minus root 21 all over 2. So if I stick that in the calculator, that's going to give me 2 answers. Let's just stick that in the calculator. So root 21 plus 1 and then divided by 2, and that gives me 2.7912. I'll call it 13. Okay, so I'll just drop it at 5 significant figures. And then the other answer is going to be 1 minus root 21 and then divided by 2. And if I decimal that on the calculator, it gives me minus 1.7913. So that's to 5 significant figures, and that's to 5 significant figures. Obviously, that's exact. So maybe give it in the exact form if you want to be really perfect about things. Okay, so we can already solve an equation like that. So we don't need to use a graphical method to solve that. But what about this? X cubed equals 10 minus 5x. Well, there is a cubic formula, but it's a little bit more complicated than the quadratic formula. But the most difficult thing about the cubic formula is you can't use it unless you know complex numbers. So it's a much more tricky thing to use the cubic formula to solve this. So for this, as GCSE students, we can't solve that using an exact method. So I haven't taught you how to solve cubics. You do learn a bit of that at A level, but even an A level pupil would struggle with a complicated algebra needed to solve that. You might also come across stranger equations like 2 to the x equals 6 minus 2x. Now these are both polynomial equations. So this is a polynomial and this is a polynomial. But this is a mixed equation because this part here is exponential and this part here is polynomial. So this is a mixed equation. They're always a little bit trickier to solve. And sometimes we don't have a direct method. And that one in particular, 2tx equals 6 minus 2x, we can't solve that exactly using algebraic methods. So we're going to have to switch to some other different style of different technique. And we could turn to an approximate method to solve equations like that. So to start with, we're going to stick with equations that we can already solve, like this one here. We could solve this, and we're going to stick to things like that, which we can already solve using algebra, so we don't need to use approximate methods to solve them. But the reason I'm sticking to them is because then we know what the answer should be, and we can just verify that the answer we get using the approximate method is quite close to the exact answer we'd get using the direct method. So that's why I'm sticking to easy questions, but then we'll move on to ones that we could never solve using algebraic methods. We'd have to use a graphical method or an approximate method to solve them. Also, the graphical methods are important later on when we come to solving inequalities, because if you want to solve anything other than a linear inequality, say for instance a quadratic inequality or a cubic inequality, or any type of nonlinear inequality, then you must do it using a combination method which involves a graph. You must always have a graph involved at some point. Okay, so back to this. So this is the same equation as we had here. That's that same equation here. And we're going to use a basic method for graphical solutions. And this basic method, we're just going to split the equation without even bothering to rearrange it first. So we're just going to split it at the equal sign. So snap the equation at the equal sign. So we're going to have this half and then this half separate, like that. Step 2, put a y equals in front of each of them. So put a y equals in front of that and put a y equals in front of that. So I put a y equals in front of both of them. Okay. So now what we have is simultaneous equations. So we went from just a single equation in one variable to simultaneous equations, which is two separate equations, and we now have two variables. The y is sort of something that we've added in. It wasn't there in the original setup at all. So just remember the y values are not really important. Sketch both curves. So I've already sketched the x squared minus x. That's already sketched for you there. And maybe I plotted these points. I put in minus 2 into the equation, put in minus 1, put in 0, put in 1, put in 2, put in 3, and then plotted those points and then did the nice curve connecting those points together. The line y equals 5 is easy. That's just a horizontal line like this. It's just going to be a horizontal line. Let's do it in a different color. Let's do it in green. It's just going to be a horizontal line like that at 5. Okay, so what we have now is we have this equation here, which is y equals x squared minus x. And then we have this equation here, which is y equals 5. And we're just going to find where they meet each other. So we're just going to find where they meet each other. Find the x coordinates where they meet, and not the y coordinates, just the x coordinates where they meet. So we're just going to identify these 2 points where they meet. So I'll just try and draw it on here. I'll draw it using a thin dotted line. There's one of the places where they meet, and then here's the other place where they meet. And I'm looking at those two x values, and that looks like minus 1.8 and that looks like 2.8. So minus 1.8 and 2.8 are my approximate solutions. Okay, so just to do it slightly better, so the same thing, but now I've put it into GeoGebra. So we've got the same two equations, and then I'm just going to click on locate and ask it to find where they meet. And it's found this point here where they meet. And it's found this point here where they meet. And again, I can see it's pretty much the same thing, minus 1.8 there. I mean, I could have got GeoGebra to read out those numbers to me, and I could have got it to read out those numbers to me to whatever level of accuracy I liked. But it's just the graph paper on here, the grid on here with the graph paper behind it, is a little bit clearer to see than on that other one. So, okay, so what do we have then? We have minus 1.8 and 2.8 as our solutions. So we've got x equals minus 1.8 and x equals 2.8. And I would say they're both to one decimal place. One decimal place. That's, I think, how accurately I could read from the GeoGebra thing. And if you look back at the answers that we got for this when we worked them out before, over here, oh, way back here, we got minus 1.79, minus 1.8, and 2.79, 2.8. So those are good to one decimal place, those two values that we got. So obviously you're limited by the size of the graph that you've drawn as to what accuracy you can infer. Okay, so that was simply just splitting it. But now we're going to not just split it anymore. We're going to do something before we split it. And the reason is we might already have been given a graph. And so if you just split it here, then you'd have to have y equals 2x squared plus 4x meeting y equals 4. And you might not already have the graph of 2x squared plus 4x, but you might have a graph of x squared just knocking around from having plotted it earlier on. You might just have that already. So you think to yourself, well, how can I utilize the graph that I've already got? Okay, so the method here is we're going to use this graph of y equals x squared to solve this. Okay, we're not just going to split it, we're going to make sure we use the graph of y equals x squared. So the aim is to rearrange the left-hand side of this equation, the one that we're trying to solve, so that it matches the one that we've plotted. And the one that we plotted is y equals x squared. So we need this 2x squared plus 4x to just become just x squared. So the 4x has got to disappear somehow and the 2's got to disappear somehow. We just want this to be x squared. So step one is start by making the x squared term the same by multiplying or dividing. Okay, I think I understand what they're saying. They're saying, look, you've got a 2x squared here and you want it to be an x squared, so just divide it by 2. So my equation is 2x squared plus 4x equals 4. And if I divide through by 2, divide by 2, divide by 2, divide by 2, then I'm just going to get an x squared here. So x squared plus 2x equals 2. Okay, so that's made the x squared match that. That matches that now. Okay, so that's just shown that a little bit neater. Times by a half is the same as divide by 2. Okay, so step one is make the x squared term, and then step two, now match the x term and units terms by adding and subtracting. Well, this doesn't have any x terms, and we've got a plus 2x here, so we need to just get rid of that plus 2x. So what we're going to do is minus 2x from both sides. And so our equation is going to be x squared equals 2 minus 2x. X squared equals 2 minus 2x. So what we've done is rearrange this equation into that. All we've done is just rearrange the equation that we're trying to solve. So that's just showing the same thing more neatly. And now we can split it. So it matches now, and because it matches, we can split it. So snap the equation at the equal sign. And so you get y equals x squared on the left-hand side, meets, and then on the right-hand side, y equals 2 minus 2x. So obviously, we've already got this sketched here. That's that one there. So what we need to do is add on the line y equals 2 minus 2x. And that's quite an easy line to add in. It's going to have an intercept of 2. So it's going to start from here. Let's just make that nice and small. It's going to start from here. And then it's going to have a gradient of minus 1 up, 1 across. So, minus 2 up. The gradient is minus 2. So gradient is minus 2, which is minus 2 over 1, which is minus 2 up, 1 across. So minus 2 up, 1 across. Oh, okay, I can't really do that very easily because this is done in 0.3s. So I can do 0.9. I can't do 1 across. I know. Why don't I do that? Multiply the top and bottom by 3. So that's going to be the same as minus 6 up and 3 across. Okay, I can't go 3 across because it only goes up to 1.8. So I'll do it backwards. So I'll go 6 up and minus 3 across. So 6 up So from here, 6 up and then -3 across, which would be there. So my line's going to connect those 2 points together. So my line is going to connect those 2 points together. Let's draw it in green. So it's going to connect. Oh, missed both the points. Never mind. I can fix that by just sliding it a little bit. Okay, so that's going to be my line. And where they meet is going to give me my solutions. So there's the line. And this is the line we've added into the diagram. So let's just write that on the diagram. So that is, let's do it in a pale blue. Don't we have a pale blue? Okay, let's do it in that. So y equals 2 minus 2x is that line there. And of course, this is y equals x squared. So that is y equals x squared. And we're just going to try and find where they meet. So we'll find where they meet. It's just going to be here and here. And again, it's not going to be easy to read because my graph is too tiny. So I'm going to switch to a bigger, clearer graph to see where they meet. So it's the same thing, x squared and 2 minus 2x, but you've got a much nicer bit of graph paper here behind here. And then I'll ask it to find where they meet. So it meets there. And again there. So that looks, okay, so this is going up in, oh, whoops. So this is going up in 0.2, so minus 2.2, minus 2.4, minus 2.6. That looks like minus 2.8. I mean, it's not quite minus 2.8 because you can see it's probably minus 2.75, but I'm just going to call it minus 2.8. So I'm going to call that minus 2.8 and I'm going to call that 0.8. So I'm going to say my answers are minus 2.8 and 0.8. So x equals minus 2.8 and x equals 0.8. And those are to the nearest 0.2, nearest 0.2, because my grid only had lines marked at every 0.2, so I don't think I can do it to the nearest 0.1. I'd need a better graph than the one that I had there. Okay, so same thing, but this time we're trying to use the graph of y equals x squared. So it's the same as the last time. So same thing here again. That's the same question as us that we just did. So that's exactly the same question with the same answers, and it's just for me to show you the GeoGebra app. Okay, so this is your first question that you need to submit. So you don't need to have the graph and you don't need to add the line. You just need to say what is the equation of the line that needs to be added to the grid of y equals x squared. So we've already got this grid and it's already got y equals x squared drawn on the grid. And this is the equation we want to solve. So you've got to do the same thing as last time. You've got to make sure that the x squared, so you've got to rearrange this one, the green one. And you've got to make sure the x squared matches this x squared. So instead of having a 2x squared, you just want a 1x squared there. You do that by multiplying and dividing. And then you use adding and subtracting to make sure there's no other terms, because we don't want anything other than the x squared. So multiply or divide to get the x squared term the same. Add and subtract to get the x term the same. Add and subtract to get the units term. Split and put a y equals in front of each expression. And then add the line to the grid. You don't need to do the bit where you add the line to the grid and find where they meet. You just need to tell me what the equation is. So that's... oh, what's that little creature crawling across the bottom of the screen? Okay, let's get rid of that. So this time they've drawn this graph here. Y equals brackets x plus 2 brackets x minus 4. And this is what we need to solve. Okay. So what I'm going to do first of all, just to make the comparison easier, is I'm going to multiply out these brackets. So I'm just going to multiply out these brackets. So that's going to give me y equals x squared minus 2x minus 8. So that's the same as that. So I'll just replace that with y equals x squared minus 2x minus 8. Okay, so that means I need to make this match there. And the first thing I've got to do is make the x squared term match by using multiplication and division. So I'm going to divide by 4 to get the x squared term to match. So I'm going to times a quarter, times a quarter, times a quarter, times a quarter. Do it to every term. And so it's going to be x squared minus 9 over 4x minus 2 equals 0. Now last time I had to just get x squared on its own, but this time this graph is x squared minus 2x minus 8, so I need this to be a minus 2x. And at the moment 9 over 4 is 2 1/4, so it's minus 2 1/4x. So I'm going to add a quarter x to both sides. So add a quarter x, add a quarter x. So that's going to give me x squared minus 2x minus 2 equals a quarter x. And then, so this bit, so far it matches. So far that bit matches with that, and that bit matches with that, but the last bit doesn't match. This bit doesn't match. So I'm going to have to make that into a minus 8, and the way I'll do that is by minusing 6 from both sides. So I'm going to subtract 6 from both sides. So minus 6 minus 6. And so that's going to give me x squared minus 2x minus 8 equals a quarter x minus 6. And now it fully matches. The left hand side fully matches. So now I can split it. So I'm going to get y equals x squared minus 2x minus 8 meets y equals a quarter x minus 6. Okay, so I need to add y equals a quarter x minus 6 to my grid. Okay, so the y-intercept for that is going to be minus 6, and the gradient is going to be 1 over 4, so 1 up, 4 across. So gradient is going to be 1 over 4, 1 up, 4 across. So I'm going to go 1 up and then 4 across, which is there. Okay, and then I'm going to connect those together with a straight line. Let's do a green line, make it a bit thin. Okay, so there's my line, just elongate that a bit. Okay, and then try and read from my graph what my solutions are. Again, it's not the best graph because it's so small, and I've only marked that every half. So I'm going to switch to the GeoGebra graph. Okay, so there's my GeoGebra graph. Same equation, a quarter x minus 6, and I'm going to ask it to locate the solutions. Okay, so my minor grid lines are at every point 2 again, and so I can only read it really very accurately to the nearest point 2. So that's pretty much 3. I mean, I think it's 2.95 or something like that. That'll be 2.8, and that'll be 3, and it's not in the middle, so it's not 2.9, it's above 2.9. I think it's about 2.95, but I'm not sure I'm okay to read to that level of accuracy. So, but I'll try it. 2.95, and then this one here is minus 0.2, 0.4, 0.6. Sort of looks like about 0.7. Yeah, sort of looks like about 0.7. So maybe 0.65. So I'm going to say that my answers are minus 0.65 and 2.95. Minus 0.65 and 2.95. X equals minus 0.65 and x equals 2.95. And I'm going to say that's to the nearest 0.05. I think I've overstretched myself in terms of how much accuracy I could read from my graph, because I probably couldn't read it to the nearest 0.05. What line should be added to y equals x squared to solve 3 over x equals x minus 1? Okay, so what that means is I need to rearrange this equation so that I can utilize this graph here. So I want an x squared in this equation. And once I've got an x squared, I just want to get it on its own. Now, what I could do is I could start by saying 3 over x equals x minus 1. And I can multiply by x cubed. So times by x cubed, times by x cubed, times by x cubed. And then that's going to give me 3x cubed over x, which is 3x squared, equals x to the 4 minus x cubed. And then I could divide by 3. So that's going to give me x squared equals a third x to the 4 minus a third x cubed. Now the problem with that is, although on the left hand side you've got y equals x squared, on the right hand side, what is this? It's some horrible equation. It's a third x to the 4 minus a third x cubed y equals. Now, although we've got the graph of y equals x squared, this isn't a line. This is a curve, and it's going to take a bit of messy plotting. So I'm going to suggest maybe that wasn't a good idea. So let's go back to the beginning and let's think about a different way of doing it. Let's make this one into the x squared. So I tried to make this one into the x squared. Now I'm going to suggest we instead try and make this one into the x squared. And so I'm going to times by x this time. So times x, times x, times x. And so that's going to give me, that's going to cancel out. So it's going to be 3 equals x squared minus x. And then now I'm just going to move the x across. So 3 plus x equals x squared. I added x squared to base. I should have shown my working, but I was feeling a bit lazy. And then we've got y equals 3 plus x meets y equals x squared. And so y equals x squared is already on the grid, and we just need to draw the line 3 plus x. 3 plus x has got an intercept of 3 and a gradient of 1 up, 1 across. So 1 up, 1 across. Okay, so it looks like this. Let's draw it in green. Let's make it a bit thin. And let's try and start it from there. Okay, and so there's our graph. And then again, we can try and read it as accurately as we can. To be honest, they're not asking us to solve this equation. They're just asking us what line should be added. And so the answer that we need to give is this, 3 plus x. Okay, so this is your second question. What line should be added to 1 over x? So you've already got a graph of 1 over x. So you want in here to achieve a 1 over x on one side. It could be on the left hand side or it could be on the right hand side. It doesn't matter which side it's on. And nothing else on that side. And then whatever's on the other side should be a line. Should be y equals mx plus c. That's your third question. Sorry, that's your second question. Okay. Finding the equation that's solved where two curves meet. So imagine a student was solving one of the questions from earlier on, and we stole her final page of her working. And we saw that her final page of her working had these two graphs on it. It had this graph here, y equals x squared, and it had this graph here, y equals 2 minus x. Then we could deduce what she was trying to solve. We could deduce that she was trying to solve the equation where x squared meets, where y equals x squared meets y equals 2 minus 2x. In other words, x squared equals 2 minus 2x. In other words, x squared plus 2x minus 2 equals 0. So this was the equation that she was trying to solve. So in a sense, this is much easier because we just need to work backwards, and it's easy to work backwards in these questions. So whatever her solutions are, I mean, and I can't actually see what her solutions are, but they're here and here. So maybe 0.75, I'm not sure how well I'm reading that, 0.75 and minus 2.75. Maybe those are her solutions. And those are her solutions to this equation here. Okay, and they'd be approximate, they wouldn't be very accurate. what quadratic equation is solved where these two curves meet? So it's saying what quadratic equation in the simplest form is solved where these two curves meet. Okay, the only trick they've put in with this one compared to the last one is in the last one we could see the equation of the green line. But in this one they haven't told us the equation of the green line. I mean, that's them trying to be like, oh, look, we've made it so hard for you. It doesn't make it particularly hard, to be honest. I could easily find the equation of that line. I'll pick 2 points on the line. I want some integer points. So there's an integer point, and that's not going through any integer point. Ah, that looks like an integer point. That looks like 2 and 5. And so how much do I have to go up? So from 2 to 5 is up 3. And how much do I have to go across? From 0 to 2 is 2. So across is 2. And up is 3. So gradient is up over across, which is 3 over 2. So this equation is y equals 2 plus 3 over 2x. So that's the green line. So essentially what we have is y equals x squared meets y equals 2 plus 3 over 2x. In other words, x squared equals 2 plus 3 over 2x. Now I'm just going to make that equal to 0 because a lot of the time when we're solving polynomials, we solve them by making them equal to 0. So I'm going to take the 2 over the other side and I'm going to take the 3 over 2x over the other side, so minus 2 and minus 3 over 2x. And so that gives me x squared minus 3 over 2x minus 2 equals 0. And it says in its simplest form, the simplest form would be that all of these coefficients are integers. So this coefficient here is 1, that's an integer already. This coefficient here is minus 3 over 2, which is a fraction, it's not an integer. And this coefficient here is minus 2, that's an integer. I'm just going to multiply through by 2. So if I times everything by 2, that's going to tidy it up a little bit. 2x squared minus 3x minus 4 equals 0. So that's the polynomial that's being solved where these two meet. And again, you know, we could maybe try and look up where those two meet, and that will be our approximate solutions to this polynomial. So this is your equation 3. And you can see that one of the curves is y equals x cubed. The other one, the line, they haven't told you the equation of it, but I'm sure you could deduce what the equation of that is. You can see some whole number points that it goes through. So the whole number points would be this one here, and then maybe this one here, and the gradient is up. Oh, well, actually, you wouldn't go up, you'd go down, but down is just negative up. So you'd go negative how many up? And then how many would you go across? So that's from 10 to 0, and that's from 0 to 2. Gradient is up over across. Gradient is up over across. There's obviously a negative gradient line because it's going downhill. And then you make that equal to x cubed, and then you just tidy up your equation to give it in its simplest form. What equation is solved where these two curves meet? So again, same sort of situation. We can see y equals 2 to the x. We don't know the equation of this line here, but it's pretty easy to work out the equation of the line because you can see these are integer points, minus 2 up, 1 across. So the gradient is minus 2. So the green line is y equals 6 minus 2x. And then the purple line is y equals, the purple curve is y equals 2 to the x. And we're trying to find where they meet each other. And so we'll be solving 6 minus 2x equals 2 to the x. You can leave it like that, maybe just make it equal to 0. 2 to the x plus 2x minus 6 equals 0. And that's the equation that's being solved. And that, the solution to that equation, we are told, so somebody's read it quite accurately off the graph, it's 1.54. I'm sure that's to 2 decimal places. And so that's our solution to that equation there. And this equation we could not solve by a direct method. We'd have to use an approximate method. So we couldn't get the exact answer to that equation. Okay, so Right, these are the questions we're going to do in class. So when you look at the bottom of this video, you'll see details, and if you click on details, you'll see a link to print y equals x cubed. There'll be a nice PDF with that on it, and you can print that. And then it's saying what line would you add to the printout in order to solve this, or solve this, or solve this, or solve this. You can see they got quite complicated by the end here. And then give the approximate solutions and verify your solutions. We're going to do that in class. So if you've done the printout already, you can bring the printout with you to class, and you might have even looked at the questions and how to go at them. And then the remaining 3 questions, so that's your first 4 questions, and your remaining 3 questions are, what is the equation that's solved where these two meet? What is the equation? And you can see I haven't given you the equation of the blue line here, like that. This is a weird one. The green one is a weird looking equation. It's called a semicubical parabola. It's y cubed equals x squared. So the name of that is a semicubical parabola. You don't need to know that name of that graph. It's more complicated than a graph that you'd be presented with at GCSE. But we're not doing anything complicated here. We're just trying to find the equation that's solved. So again, the blue line, you haven't got the equation of it. Okay, don't forget to prepare for your test. Preparation is key to getting a good mark in the test, and getting a good mark, getting regularly 4 or 5 out of 5 in the test is the key to doing well in your GCSE. So make sure you've done that. I will see you in the next lesson primer, and Menna will see you in the classroom. Bye.